Hey everybody, it's Shelby, and today we're going to be doing an interactive case study number 7 of 8. We just have one more left to go next week, and this one is about Fluorouracil. So, the description for today's case study is that Fluorouracil, or 5FU, full trade name Fluorouracil, is used to treat various forms of cancer, including colon, breast, and then digestive tract. Fluoropyrimidines were developed in 1950s under the observation that rat liver cancer cells use uracil more rapidly than normal tissue. The combination of 5FU with newer chemotherapy has improved response rates for advanced stage colorectal cancer by a dramatic 40-50%. Upon uptake from the cell, 5FU is converted to 3 different analogs: fluorodeoxyuridine monophosphate (FDUMP), fluorodeoxyuridine triphosphate (FDUTP), and fluoridine triphosphates (FUTP). So I know we discussed this last week, so we've kind of been talking about cancer for a couple of weeks now, but we'll just do a brief rundown of it again. That way we all have a understanding before we continue. So cancer is a disease in which some of the body's cells grow unconditionally and spread to other parts of the body. There's 2 different types of cancer cells. There's benign, which are non-cancerous, usually doesn't grow back, or malignant, which is the cancerous form, and they can grow back tumors. Sometimes cell division breaks down and abnormal or damaged cells grow and multiply when they shouldn't. Then tumors develop, which are lumps of tissue. Tumors can remain in one place or can spread and form new tumors, which is metastasis, and solid tumors or in the blood. Cancer within the blood is leukemia. So here is the difference between cancer cells and normal cells. So normal cells, there's a large cytoplasm, single nucleus, single nucleosis, and they have fine chromatin, versus a cancer cell, which is the exact opposite. They have a small cytoplasm, multiple nuclei, multiple nucleoses, and they have coarse chromatin. They grow uncontrollably. They ignore signals that tell them to stop dividing, and go into apoptosis, which is cell death. They invade into nearby areas or other areas of the body. They tell blood vessels to grow towards tumors, and these blood vessels carry oxygen and nutrients that help these cancer cells keep growing and dividing and making the cancer more worse. They hide from the immune system and trick it. They change multiple chromosomes, and they rely on different types of nutrients, allow them to make energy differently and survive against the body's wishes. So there's all different types of cancers, causes of cancers. It's essentially just an error as cell divides. And carcinogens, which are things that cause cancer. Some things include, chemicals, ultraviolet rays, your diet, your hormones, your radiation, your obesity, if you have chronic inflammation. It can be inherited from your parents or your grandparents. If you smoke, if you drink a lot, exposure to a lot of sun without proper protection. So now let's get more into the molecular part of things here. So we're going to talk about uracil. Uracil is a nucleotide base in RNA. It pairs with adenine, which is the A in all of the bases. So DNA, there's 4 different bases. There's cytosine, guanine, adenine, and thymine, which is what uracil, which is the nucleotide base only found in single-stranded RNA, is different. So, in DNA you have ACT and G, and then in RNA you have ACG and U. So, it replaces thymine. These 2 replace each other. Notice that this only has a single hydrogen, and this is carbon with 3 hydrogens. This nucleotide contributes to the ability of RNA to be degraded easily, which we will talk about why that's important in a few slides here. So, now let's talk about the drug that most affects uracil whenever a cancer is involved. So, what is fluorouracil? It's a chemotherapy drug, also called 5-FU, a topical cream, or it can be injected. It's used to treat neoplasm, which is abnormal mass of tissue that can be benign or malignant. Is used to treat various types of skin cancer as well as the one mentioned before, like the breast, the colon, all that stuff. It mimics one of the building blocks of RNA, uracil and thymine, for DNA, allowing the growth of cancer cells to stop or slow down. And whenever it stops or slows down, it triggers apoptosis, aka cell death. So, there's 3 different pathways that can go down just based on what it's transformed into, but we'll kind of briefly discover them, or talk about them. So, it's important to note that whenever you put on this cream, only 6% of the dose is taken up by the body. And whenever it is injected intravenously, IV, it starts working right away. It rapidly goes into cells through facilitated transport pretty much right away. So, the mechanism of action, or how it inhibits RNA synthesis, is that FDUNP binds to an enzyme, thymidine synthase. This complex inhibits the production of DTMP, which this molecule is important for DNA repair and replication. And a depletion of this molecule causes an imbalance within nucleotides, causing the double strand of DNA to break by the endonucleases, which is our enzymes. For RNA, though, we have this drug, and then this drug is converted into fluorouracil triphosphate, which is a fraud. It's a fake nucleotide, not allowing RNA polymerase to synthesize, so then it leads to no RNA synthesis. Which, if there's no RNA synthesis, you can't make new cells. Cancer cells die. It's a protein analog by misincorporation into RNA and DNA instead of the uracil or thymine. Topical use has a selective cytotoxic effect on the infected skin, leaving normal skin untouched, which is very important for some people. And it also increases P3 expression, which is very important to note, because we've talked about that before in previous weeks. So, as you can see here, you have kind of a schematic of what we talked about before, and this is metabolized in the liver, and it's excreted through the urine. So yeah, you have the drug, and it goes into different things as we discussed earlier, all leading to DNA damage and thus leading to increased P3 expression, which causes the cell to slow down its division or stop its division, thus leading to apoptosis, cell death. So, adverse effects of this drug include a skin rash, could have some itching, could have some hives, could have some face swelling, lips or tongue swelling, a fever, chills, stomach pain, vomiting, redness or dry skin, and also some sensitivity to light. It's highly recommended that whenever you're on this drug, whether the injection or topical cream, is to kind of stay out of the sun, which is pretty hard for some people, especially, me, if I ever, God forbid, had to be on this drug. But yeah. So, here are my references, and yeah, this was case study number 7, 7 of 8, so we're getting there. Bye.